In this lesson, you will learn to apply the zero factor property to solve quadratic equations. Quadratic equations in standard form. An equation can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, with a not equal to 0, is a quadratic equation. This form is called standard form. Solving an equation by the zero factor property requires that you make sure that the equation is in standard form before factoring. So here are the steps for solving a quadratic equation by factoring. Step 1, rewrite the equation in standard forms. Now, standard form is nothing more than all your numbers on the left and 0 on the right side. That's standard form. Step 2, factor the polynomial. Step 3, use the zero factor property, in which you're going to set each variable equal to 0 and solve for x. Step 4, find your solutions. And then step 5, it's always a good idea to check your solutions. So instead of talking through all of the steps, you may not remember them. It's best for me to actually talk you through the demonstration of actually solving a problem. So let's get started solving a problem by factoring. In this example, we're asked to solve the equation by using the zero factor property. Step 1 in solving a quadratic equation by using the zero factor property is to make sure that the equation is in standard form. And recall, standard form is where your square term is first. So degree 2, degree 1, then your number, and they're on the left side, and 0 is on the right side. When you have it in that form, that is called standard form. Step 2 is to go ahead and factor the equation. We covered factoring trinomials in previous sections, so I'm not going to go over how to factor. You should already know how to factor. So the next step after I factor it is to take each parentheses and set them equal to 0 so that I can solve for x. So I'm going to set x plus 4 equal to 0, and then x minus 5, I'm going to set it equal to 0. Now I need to solve them both for x. So starting with the first one, in order to solve for x, I would need to subtract 4 from each side. When I subtract 4 from each side, x will equal -4. For the other one, to solve for x, I would need to add 5 to each side, and x equals 5. So my two solutions are x equals -4 and x equals 5. You say, what are these solutions are about? Well, when they ask you to solve an equation using the zero factor property, what they're really asking you is to identify the number or numbers that would make that equation zero out. What equations will cause it to equal to 0? What numbers would cause it to equal to 0? And with those solutions, what we're saying is that the numbers -4 and 5 are the numbers that would zero this equation out. There are no other numbers in the world that will zero this equation out other than those two numbers, and those are our two solutions. Let's check those solutions. If we were to plug that solution of a 5 and a -4 back into the original equation, whether I plug it into the standard form or whether I plug it into the factor form, it does not matter. But what's going to happen when I plug those numbers in is it's going to cause the equation to equal to 0, to result in a 0. So here's the factored form. If I plug in a 5, remove the x's and replace it with 5 and do the math, I have 5 take away 5 is 0. 5 plus 4 is 9. 9 times 0 is 0. So notice by plugging in a 5, it zeroed the equation out. So that is proof, that's true, that 5 is one of our solutions that would zero the equation out. Let's see if 4 will cause the equation to zero out. So if we were to plug -4 into our equation, we have -4 combined with a -5, which is going to give me -9. These 4's are opposites of each other. They're going to cancel out to 0. -9 times 0 is 0. So again, we see here that our two solutions are the numbers in which would zero the equation out, and that is -4 and +5. Now, you don't have to go through that whole process of checking every solution. If you're not sure whether the solutions that you have are indeed the true solutions, then you can plug them in and always check by plugging it back into either the factored form or the standard form of it. It doesn't matter. But if it zeroed the equation out, then there you have it. That is your proof that that's your solution. The next example, we're asked to solve the quadratic equation by using the zero factor property. So again, this one is in standard form already, so let's proceed with factoring it. This factors into x minus 3 times x minus 3. In other words, a binomial squared, because actually what this is a perfect squared trinomial, which factors into two binomials. So next we want to take them and solve for x. Now it doesn't matter if you take both of them and set them equal to 0 and solve for x. For both of them, you're going to have to wind up adding 3 to each side. And what you get for your solution is 3. So in this case, we only had one solution. We're asked what number would zero this equation out. There is only one number in the world that will zero this equation out. And that one number is 3. And there you have it. That is your solution to this quadratic equation. In this next example, we're asked to solve this quadratic equation by using the zero factor property. Well, step one is to make sure your equation is in standard form. So this particular equation is not in standard form, because notice here that we have a number on the right side. In standard form, recall, is where all your numbers are on the left side and 0 is on the right. So what is the first step you need to do to get this in standard form? If you said to subtract 5 from each side, then that is correct. So let's do that first. We need to move 5 on the other side, and to do that we have to subtract 5. And so now that we have it in standard form, our next step is to go ahead and factor the trinomial. Next, I want to take each parentheses and set them equal to 0. So I'm going to set 2x plus 5 equal to 0, and then I'm going to set x minus 1 equal to 0. Now I want to solve both of these for x. So for the first equation of 2x plus 5, what is the first thing I need to do to solve for x there? Yes, that is correct. I'm going to subtract 5 from each side. Last step to solving that is to do what? Divide by 2. And x equals -5/2. Very good. And the other one, all we need to do is one thing. And what's that? That's correct. Add 1 to each side. And so our two solutions then are -5/2 and 1. Those are the two numbers that would zero this equation out if we were to go plug them back in. Now we're not going to check from here on out. I showed you how to check if you were not sure of your answer, but here our solutions are -5/2 and 1. In this example, we're asked to solve this equation by using the zero factor property. And again, keep in mind with the zero factor property, all they're asking us for is to identify the numbers which would zero the equation out. And in order to do that, we have to follow the zero factor property. So step one is to make sure your equation is in standard form. Our equation is in standard form. We have all our numbers to the left, zeros to the right. Our next step is to factor it. And what I see here with this binomial, I have two perfect squares. And by the way, there's no GCF inside because 7 times 7 is 49. And there's no 7s inside of a 9. So there's no GCF, but they are perfect square roots and they have a minus sign between them. So that's a difference of square, which we can factor. The square root of 49x squared is 7x. The square root of 9 is 3. So what we're going to have is, when we factor that difference of square, 7x plus 3 times 7x minus 3. Next, we're going to take each parentheses and set them equal to 0 so that we can solve for x. Anytime you have a difference of squared, you're going to have two solutions which are opposites of each other because they have different signs. So on one of them, you're going to have to subtract 3 from each side. The other one, you're going to have to add 3 to each side. And with both of them, you're going to divide by 7. And again, your two solutions will always be two solutions in which they are opposites of each other. And those are the two numbers that would zero this equation out if we were to plug it in. And there you have it. We've solved this equation using the zero factor property. In this example, we're asked to solve the quadratic equation using the zero factor property. So step one is to make sure your equation is in standard form, and yes, it is in standard form. All our numbers are on the left, 0 is on the right. We have a binomial here, and it is not a sum of squares because 3 is not a perfect root, and neither is 7 is not a perfect square root. It wouldn't be a sum of cube because this is a 2. If this were a 3, then maybe you would be looking at something different. But what we want to look at is we want to first determine if these two numbers have anything in common. Let's see if we can take a GCF out. So we look at the smallest number, which is 3, and we ask ourselves, is there a 3 inside 27? And yes, there is. So recall that if it starts with a negative, you factor out a negative. So let's factor out a -3 from that binomial. Now, the only reason why we were checking to see if it was a sum or difference of squares is you have to do all that checking when you're looking at terms. You first check to see if there's a GCF. If not, you check to make sure check to see if it's a difference of square. Check to see if it's a sum of square. All of that checking process is necessary because it determines your next move in that problem. But in this case, this was one that had a GCF, so that is always first, is to take your GCF out, and then whatever is left goes in the parentheses. Notice here what we're left with is a difference of squares. Again, we have two perfect square roots with a minus sign between them, so that's a difference of square. The square root of y squared is y. The square root of 9 is 3, so what we're going to have there is y plus 3, y minus 3, with your GCF on the outside. We are not done yet because we're using the zero factor property, which states that you're going to take each parentheses and set them equal to 0 and solve for x. And actually, it's not just parentheses, it's anything that has a variable. The reason we take the parentheses and solve them for x is because they contain a variable. Okay? Now, we cannot take -3 and solve it for x because you don't have a variable. In this case, it's y. Actually, we're solving for y. But you can't solve for y if you don't have a y here on the outside. So we're only going to take the parentheses and solve them for y. So on the one, I'm going to have to subtract 3 from each side. On the other, I'm going to add 3 to each side. And my two solutions then are going to be -3 and +3. And there you have it. Those are the numbers that would zero this equation out. Again, -3 is not part of the solution because it does not contain a variable. You cannot solve for y with that -3 because there's no y out there. Let's solve this equation using the zero factor property. So step 1, let's look at all the terms and see if there is something that they share in common. In other words, let's find out if there's a GCF. So in looking at the smallest number is a 1, so all numbers share a 1 in common. Let's move on to the variable, the y. At most, how many y's do they share in common? Yes, they share one y in common. So that y is your GCF, so let's go ahead and take that GCF out, and what's left goes in parentheses. When you are left with the highest degree term being a squared term, so you have a degree 2, a degree 1, and a constant, you should always try to factor it further if possible. So let's go ahead and factor that trinomial into two binomials with the GCF being on the outside. Our next step for the zero factor property is to set all parts containing a variable equal to 0 so that we can solve for x. So any part that has a variable must be set to 0 and solve for x. So we're going to set the outside equal to 0. We're going to set 2y minus 2 equal to 0. And we're going to set y minus 9 equal to 0. So when we do that, it looks like this. And so one of them, the first one is already solved for you, y equals 0. For the second one, to solve for y, we would need to add 2 to each side. And for the last one, to solve for y, we would need to add 9 to each side. And here we have 3 solutions. Our solutions are 0, 2, and 9. And there you have it, solving an equation using the zero factor property. Now, just in case you wondered why the y is a part of the solution and the problem previous to this one, the -3 was not part of the solution. The reason the -3 was not part of the solution was because it did not contain a variable. But anything that contains a variable and is on the outside, you must also set that equal to 0 and solve for that variable. And there you have it, zero factor property. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.